Good afternoon, everyone. Today, we are going to discuss in around 2 minutes regarding the basic concepts of MRI. I think all of us clinicians have heard about the term MRI, and we basically prescribe it in a lot of conditions, and we are quite used to saying it. But initially, to start with, it's a difficult concept. What exactly is an MRI? And it really becomes quite difficult in the rounds, and while we are in the bedside to discuss what exactly is an MRI. So I'll just be discussing in around 40 to 50 seconds like what is an MRI is. So let's start with the basic concept. So how do I try to remember it in clinical scenarios? So that is the basic funda. So I'm not trying to be exact in physics, like I can say might not be correct all the times in terms of physics, but being able to interpret clinically is the more important part. So let's start. So the first question that arises is like magnetic resonance imaging is something related with the hydrogen atom. So why hydrogen? Because our body is 60% fluid, more or less. So hydrogen is very common. H2O means there are two atoms of hydrogen linked to an oxygen. So hydrogen is like a very common atom in our body. And the other thing is it has got some magnetic properties. So if you go into depth, but it's not important for clinical scenario. Basically what you're trying to look at is the hydrogen atom in the body. And so the simple fact is that if you have a watery tissue, let's say like the CSF, then more hydrogen is present in the CSF. If you have a fatty tissue, okay, let's say the fat, then it has got less hydrogen. It's as simple as that. So the water, as you can see in CSF, has more hydrogen, the fat has less hydrogen because it's more fat. So the difference in concentration is the most important thing to remember, and that is something to remember while interpreting an MRI. So now let's go into a bit of depth. So in the natural state, the hydrogen molecules are randomly moving in multiple directions. It's as simple as that. Like different friends move in different directions while moving uphill, or we are trying to walk in our own ways in life. So it's something called the spin, that is concept, but still that is not important clinically. Basically what we need to remember is that the hydrogen atoms are moving in different direction. But once we are in the magnetic field, then all the movements become uniform. Then you suddenly disturb the uniform motion using any other form of energy. Let's say we use a radio frequency wave or radio frequency energy. So what happens? The hydrogen molecules start to go back to their original random state. So what we are measuring is the time taken by the molecules to go back to their random state. So what you need to remember is that initially the molecules are in a random motion. Then once you inside the magnet, they become uniform. Then you provide some energy. Then they again start to go back to the original state. And the time taken for these molecules to go back to the original state is what is being measured in an MRI, and these are simply called as the T1 and T2. So what exactly are T1 and T2? We commonly like in our rounds we listen our consultants saying that this is a T1 weighted sequence, this is a T2 weighted sequence. So what exactly is T1, T2? Actually there's something called the echo time and the repetition time. So T1 is for fat. That's the number one thing you need to remember. T1 is fat, T2 is water. So T1 image is for fat, T2 image is for water. Now as we have discussed, fat has less number of hydrogen molecules, so definitely it will have less amount of magnetization, so it will have less echo time, less repetition time, less. T1 means less water, that is fat, less echo time and less repetition time. So whenever you call it T1, this is fat, so it has less water, that is less T1 echo time and the less repetition time, that is as easy as that. But T2 is for water, which means large number of hydrogen molecules, so large echo time and large repetition time. So whenever you are asked an MCQ like the TE and TR, then is large in case of T2 because it is for water which has large number of hydrogen molecules. Simple as that. So these values can easily be observed in any MRI sequences in your department. Now let's look at this image. It's a very simple image, like you can easily identify if you remember the concept that has been described previously. So the first image and the second image, don't focus on the third image, that we'll be discussing in some other day. So in the second image, if you look at, then you can easily identify the ventricles. Okay, the ventricles are quite easy to identify. So these are the ventricles. Now as you can see, and the other thing that you can identify is like the CSF in the subarachnoid spaces. So obviously the CSF is fluid, so the fluid is enhanced more. So obviously the fluid is enhanced more, that means it is higher TE, higher TR, that is it is a T2 weighted sequence. And again, the other thing that is quite difficult not that difficult to identify. Like if you can see these finger like projections, then these are the white matter, and outside you can see the gray matter. So if you compare the white matter and the gray matter, then you can see that the gray matter is more whitish compared to the white matter. And obviously the white matter has myelin, so myelin is fat, so fat is less T2, less Te, less Tr. Okay, and but the gray matter is white, that is it is in a T2 weighted sequence, it enhances more. But if you observe the image on the left hand side, then you can see that the CSF in the subarachnoid spaces and in the ventricles are black. But if you observe the white matter, that is the myelin, it is quite enhancing more than the CSF here and the gray matter, which is black. So simply whenever you look at the image, the first thing you have got to identify is the CSF itself. So if the CSF is white, then obviously it's a T2 weighted sequence. So it's as easy as that. But when we are discussing the other sequences, then you'll have to identify some other facts also. But for T1 and T2, just look at the CSF. If the CSF is white, it's a T2 weighted sequence. And if the CSF is black and the white matter is enhancing, then it's a T1 weighted sequence. And why is the T1 weighted sequence? You have got a higher intensity for the white matter because it is fat, it has less number of hydrogen molecules, and T1 is for fat. So that's it about the T1 and T2 weighted sequences. Thank you.